Okay, so ladies and gentlemen, you are all welcome to our today video. So today we are going to look at the concept of empirical and molecular formula. So let's start with empirical formula. Empirical formula is the slowest or is the lowest whole number ratio of element in a given compound or in a compound. So when you have a compound, so the lowest whole number ratio of the element that are present in that particular compound is what you call empirical formula. And molecular formula is a sum multiple of the empirical formula. So the multiple of empirical formula is a molecular formula, which actually show the exact number of, or which actually shows the exact ratio of elements that are present in a compound. So now, let's now look at the example. This is carbon. So for CH4, this is CH4. So the empirical formula of carbon is 1, and of course for the hydrogen is 4. So that is why we have 1:4. And of course for the molecular formula, this is a molecular formula of glucose, which is C6H12O6. And of course we can see that clearly the molecular formula is that the ratio is 6:12:1. But you can reduce it to the empirical formula. So if you reduce it by dividing through by 6, we are going to have 1:1. So therefore, in this glucose, we have 6 molecules of carbon, 12 hydrogen, and then 6 molecules of oxygen. So this can be reduced if you can now divide this 2 by 6. By 6, it will be reduced to ratio 1, ratio 2, ratio 3. So this is actually the empirical formula, and then this one is the molecular formula. So molecular formula is a multiple of the empirical formula. And then the next one is the sodium disodium tetraoxo sulfate 6. So you see that the empirical formula is 2:1. And of course, how do we get this? Because the empirical formula is a multiple of 2, and that is how the molecular formula is generated. Sorry, that is how the empirical formula is generated. And of course, we can see that we have ratio, like for example here, the the sodium have a ratio of 2, and of course the SO4, have a ratio of 4. So if you can now divide this through by 2, this 1 by 2, so the ratio is going to be 1:2. So it means that this is the empirical formula. So the molecular formula here is a multiple of 2. That is how the molecular formula of Na2SO4 is actually obtained. So then the next one is C3H6. So we have the molecular formula is C3, and then we have H6. The molecular formula is 3:6, which also reduced to 1:2. So it's a multiple of 3. So the next thing is, can an empirical formula also be the molecular formula? Is that possible? That is the question. The answer is yes. So the empirical formula of a compound can also be the molecular formula of a compound. Like for example, in the case where we have C12H22O11. So this is the empirical formula and the molecular formula of the compound, because in this case, there is no way that you are going to reduce the ratio. Because if you now say C12H22O11, if you divide it through by 2, of course, for the 11th, you are going to have a fraction. Sorry, you are going to have a decimal. So that is why the empirical formula and the molecular formula in this case are the same. So what are the steps for determining empirical formula of a compound? 1. Assume 100-gram sample when given percent. So assuming now you are given a percentage, so you assume that the total gram of that particular substance is 100 gram. If it's given in gram. And you now change the grams into moles for each element. You change the grams into moles for each element, and then you divide all the moles by the smallest number of moles to give the lowest whole number ratio. Then you write the empirical formula. So now let's look at this compound here. Let's now look at this compound. So in this case, we have a compound which was found to contain 33.11% calcium and 63.83% chlorine by mass. Then what is the empirical formula, and what assumption did you make? So I think this is simple. Since this is a chlorine, so we are going to convert this one to mole. And of course, we assume that since it is given in percentage, the total mass of the sample is 100 grams. So therefore, in step one, you are going to convert this 36.11% to mole. And how are you going to do that? So of course, we know that 1 mole of a substance contains 40.08 gram of calcium, and then you now cross multiply, and after you do that, then you are now going to get the mole. And of course, you also did do similar to this, which is the 1 mole of a substance contains 35.45 gram of chlorine, and of course, for the 16.86 gram will be in X. So after you do that, then you are now going to get the mole. So we have 0.900 mole, so 0.9009 mole of calcium. Then we have 1.802 mole of chlorine. So between the calcium and the chlorine, which one have the lowest mole? Is calcium, because the mole here is 0.90. So if you have something like this, then you are going to take the smallest mole and divide both the two moles, that is for the calcium and the chlorine. So you take the lowest possible moles and you divide through all the elements that are present in the compound. So therefore, in the step 3, we have 0.900 mole. You divide it by the same number, then we have 1.802 mole of chlorine, and you divide by 0.9009 mole. So therefore, in this case, it means that you are going to divide the mole by the smallest mole. So the smallest is 0.900. So that is why we divide that, and at the end, we are going to get our ratio. So here we have 1 mole, and of course, for this one, we have 2 mole. So at the end, at the step 4, the empirical formula is going to be CaCl. So this is how to calculate the empirical formula. And also there is another way that you can do that. Let me show another simplest way. Like for example here, let's use the other step. This is calcium, and of course, let's start with calcium. The mass of calcium, or the percentage of calcium given, is 36.11%. And of course, the molar mass, what is the molar mass of calcium? The molar mass of calcium is 14, so you now divide it by 40. And then chlorine. So the percentage of chlorine is 63.89. So 63.89. And then you divide it by the molar mass of chlorine. So the molar mass of chlorine is 35.5. So when you divide this by this, it is going to give us 0.900. And of course, if you divide this by this, that is where we are going to get that 1.8. So we are going to get 1.8. So now by looking at this one and this one, which one is the smallest? Of course, this one is the smallest, so you divide it through by this. So you have 0.90, so you now say 0.90 0, and of course here we have 1.8. So we also divide by 0.9. So this one divided by this we have 1, and then this one divided by this we have 2. So we have 1 ratio of calcium and 2 ratio of chlorine, and that is why we have calcium Cl2, that is calcium chloride, and here is 2. So this is how to calculate the empirical formula of the compound. So this is an alternative way or the other way of doing that. Then the next thing now is let's look at another example. Like for example, now a compound was found to contain 68.45% chromium, and the rest is oxygen. And of course, since this one is in percentage and we know that of the chromium, so we have to calculate the percentage of oxygen. So how do we do that? So we are now going to say, we assume that everything is 100 grams since it is given in percentage. So we are now going to say for the percentage or for the mass of chromium is, of course, it's 68.4 gram. So to get that of the oxygen, you are now going to say 100 minus 16. 100 minus 68.42, and that is how we get that 1.58 for oxygen. So now how do you convert this to mole? Of course, you just say 68.42 gram divided by 62.00, which is the molar mass. This 52.00 gram is for chromium, which is the molar mass of chromium. And of course, for oxygen, the molar mass of oxygen is 16, so we have 35.58 gram. So therefore, if we now check the percentage, we have, the mole at the end, we have 1.316 mole for chromium, and then we have 1.974 mole for oxygen. So between the mole of chromium and that of oxygen, which one is the smallest? Is that of the chromium. So we divide each to by that mole of oxygen and that of the chromium. So we have 1.316. So we divide it, and then here we also have divided by 1.316. So at the end for the chromium, we have 1 mole, and then for oxygen, we have 1.5 mole. So what do you do in this case? We can't round this off. So way too much to round off. So you have to get a root of the fraction. So how do we get this? Then you multiply all the mole by 2. So when you multiply it by 2, we are going to have the ratio of chromium as 2 and that of the oxygen to be 3. So at the end, we are going to have C2O3 as the empirical formula. So this is also another example. Ethane is a compound containing only carbon and hydrogen. So it contains 85.63% of carbon and the rest hydrogen by mass. So it also has a molar mass of 28.05. So what are the empirical and molecular formula of this compound, and what assumption did you make? So first we assume that since the carbon is given in gram, so we have to get that of hydrogen. So to do that, we have to say 100 minus 85.63%. So at the end, we'll have that of hydrogen to be 14.37 gram. So now we get the mole by dividing the mass given or the percentage given by the molar mass. So that is why we have 85.63 gram divided by 12.05. And for that of the hydrogen, the molar mass of hydrogen is 1, so we are going to use 14.37 gram divided by 1.00. And so at the end, we have 7.130 mole of carbon, and that of hydrogen is 14.21. So which one is the smallest? Is that of carbon, because it's 7.130. So we have to divide it through. So that is why for the first one, we divided by 7.130. And then for the second one, we also divide 14.26 by 7.130. 3. So at the end for the carbon, the ratio or the mole is 1 mole of carbon and then 2 mole of hydrogen. So we have the empirical formula to be CH2. And then the next thing is the molecular formula. So remember, molecular formula is the sum multiple of the empirical formula. So that the molar mass of the compound, take the molar mass of a compound and divide it by the molar mass of the empirical formula. So after you do that, then you are now going to get the ratio. So that is why we have the molar mass of the compound, which is 28.05, and then you divide it by the molar mass of the empirical formula, which is CH2. So you divide it 2, and at the end you have 2 as a multiple factor. So the 2 is a multiple factor. So that is why at the end we now multiply 2 times CH2N. And of course we have C2H4, which is the molar mass of ether. And there is also another way that you can just make this calculation to be simple. This way is like this. Initially, we have that of carbon. So to do that, we are now going to say 100 minus 85 point, we have 85.63. So we have to do that. We have 100 minus 85.63. So after we now take 100 minus 85.63, at the end, we are going to have something like we are going to have 14.37 gram. So of course, to calculate the empirical formula, we are now going to use for the carbon. Let's take it like this. For the carbon, let's start with that of the carbon. So for the carbon, we have the percentage as 85.63, and of course the molar mass of carbon is 12, so we divide it by 12, and that of hydrogen we have 14.37, and then we divide it by 1.00. So at the end, that is of hydrogen, we are now going to have something like, when we said 85.63 divided by 12, we are going to have a number like this. We have 7.14. And then if you now take that of hydrogen, we are going to have 14.37. So between this one and this one, which one is the smallest? Is, of course, is the 7.14. So now after we take this, we divide it also here through by 7.14. At the end, we are going to have the ratio of carbon to be 1, and of course the ratio of hydrogen to be 2. So at the end, we are going to have CH2, which is the empirical formula. So this is another way of doing the calculation. And of course, to calculate the empirical formula, to calculate the molecular formula, we are going to take the mass here and divide it by the mass of the empirical formula. So whatever you get as the ratio, then you multiply your empirical formula. And of course, since this is a CH2, so we have the molar mass for the empirical formula to be 14. So we now take 28.05 given from the question. Then you divide it by 14. So at the end it's going to be 2, which is the multiple factor. and then you multiply it by this, and that is why you have C2H4. So ladies and gentlemen, thank you for listening. And we are going to stop here. And if there is any question, you can ask on the comment section. And if this is the first time you are coming to my YouTube channel, please subscribe. Thank you.